Hello friends, today we will write a program in Java to find out if a number is an Armstrong number or not. So before doing that, we should know when is a number an Armstrong number. So an Armstrong number is a number that is equal to the sum of its own digits, each raised to the power of the number of digits in the number. So if you see the number 153, so 1 raised to the power 3 plus 5 raised to the power 3 plus 3 raised to the power 3. Why we have raised it to the power 3? Because the number of digits in the number is 3. Similarly, if you see 1634, the number of digits in 1634 is 4. So we have raised each digit in that number to the power 4. So if the sum is equal to the original number, then we say the number is an Armstrong number. Otherwise, we say it is not an Armstrong number, just as you see in the case of number 125. It equals to 134 when we do the sum by raising the numbers to the power of the number of digits. It's not equal, so it's not an Armstrong number. Now let's see how to do the same program in Java. So for doing the same program in Java, first of all, I will ask the user to input me the number. Suppose the user inputs me the number 153. So I need to figure out if the number is an Armstrong number or not. So I have created a method called isArmstrong, and I'm passing the number which I took from the user, and using if else, I check if the number, or I print if the number is an Armstrong number or not. So let's go to the isArmstrong method and figure out if the number is an Armstrong number or not. Okay. So first of all, I take this isArmstrong method as the type Boolean so that it tells me whether it is true or false, means whether it is an Armstrong number or not. So I take the method as the return type of the method as Boolean, and I pass on the number n as the parameter here. So now I have taken the variables temp, digits, last, and sum. So I will be telling you through the program why I have used a particular variable. So in this case, I have used the variable temp to copy the original number. See, I have original number which I need to test, but I really don't want to change the number. I do want to operate on that number, but I don't want to change the original number. So I copy it in another variable called temp, and I will operate whatever I want to do on the variable temp instead of variable n. And I will keep it safe to check it towards the end whether the values are equal or not. So suppose I take the number 153, which we just saw is an Armstrong number. Now, I take a while loop. First of all, I'll figure out the number of digits in a particular number. So like I know for the number 153, the number of digits, let me open the notepad for explanation. So in the number 153, the number of digits is 3. Now the same we have to figure out using the Java program. So the temp variable will copy the original value, which is 153, right? We have just copied it in line number 10. So in the while loop, I continue till the temp value is not 0. So first of all, I'll take the quotient. So 153 divided by 10 gives me what? Gives me 15. And digits variable is to count the number of digits. So originally it is 0. So when I do a digits plus plus, it becomes 0 plus 1 becomes 1. So I have counted the first digit. Now I go back again. I again check the condition. Temp greater than 0. What is temp? Temp is 15 now. So 15 is of course greater than 0. So I can go back to the loop again. Again, I can do 15 divided by 10 gives me what? Gives me the quotient, not the remainder. So it gives me 1. I can again go and safely increase my number of digits from 1 to 2. 1 plus 1 gives 2. See, I will increment it by 1. So the number of digits is 2 now. Now, the value of temp is 1, which is greater than 0. So my while loop can run once more. So I will go back again. Temp is equal to what? Temp is equal to 1 divided by 10, right? And I increment the digits variable. So 2 plus 1 becomes 3. So I have now calculated the number of digits as 3. See, if I go any further, the value of temp is less than 0. So the loop will not run. So I have calculated it correctly that the number of digits in the number 153 is 3. So one work is done now. So one work is done, which is counting the number of digits. I go back again and I safely copy. After the loop finishes, I safely again copy the value of n, which is 153, to the variable temp. So temp becomes 153 again. Now why I do so is I need to do the addition of the numbers raised to the power of digits. So now I call on the second while loop to do this. Okay, so how do I do it? See, so now the number is 153. Now I have another variable called temp, if you see, last, which I have given the value as 0. So what I do is now I try to find out the modulus. See, the reason for getting the modulus is to get the digit separately from the number. So first of all, I get the last digit, which is number 3. So for doing that, I have to do the modulus so that I can get the remainder back. So when I do 153 modulus 10, I get the digit 3. Then the next thing is I need to add on also, right? So how do I add on? Sum is equal to sum plus math. This is the maths class to do the exponent last comma digits. What does that mean? It means, what is last here? Last is number 3 here. The one of the digits of number 153. And digits is what? Digits is the number of digits. See, we just calculated the number of digits as 3 few minutes back. So 3 raised to the power 3 is actually 27. So I get it as 27. So if the original value of variable sum is 0, 0 plus 27 gives me 27. So now my sum becomes 27. Fine. Now I go back to line number 26. So I do temp is equal to temp divided by 10. I find out the quotient and gives me 15. So 15 is the digit which is left. Third I've taken out already. So now I need to operate on 15. Right? So I go and check if 15 is greater than 0. Yes, I can go back to the loop again. I can run the loop again. And now I will operate on last. So last will be temp modulus 10. So which is 15 modulus 10 gives me the remainder as 5. So I am able to take out the second digit now. Now, when I do so, I again go to this sum is equal to sum plus maths power last comma digits. So we had calculated the sum to be 27 in the last step. So 27 plus 5 raised to the power 3. Why? Because see, the value of last is 5 now. The value of last is 5 now, and the value of digits is 3. The value of digits doesn't change. It is 3 only. So 5 raised to the power 3 gives me 125. So 27 plus 125 gives me what? 152. Fine. So now I go back again and I do temp divided by 10. So temp is what? 15. So 15 divided by 10 gives me 1. So 1 modulus temp gives me 1, the last digit I wanted. So now again the same thing. Now my sum was 152. So 152 plus 1 raised to the power 3, because 1 is the value of last, and digits, the value is 3, right? So 1 raised to the power gives me 1 raised to the power 3 gives me 1 only. So 152 is equal plus 1 gives me 153. So now when I check n double equals to sum, yes, so n was what? N was 153, and sum I have calculated, it is anyways 153 now. So both of them are equal. So if both of them are equal, I return a true. Otherwise, I return a false. So in this Boolean method, I return a true if the value of n is equals to sum. Otherwise, I return false. I go back to the main function. And what is it? If this method returns me true. I say number is an Armstrong number. Otherwise, I say it is not an Armstrong number. So if I run the program using number 153, it gives me the number is Armstrong number. Similarly, I could have tried it with number 125. It gives the number is not an Armstrong number. So this is how the actual calculation happens, and this is how you run through the Java code. So if you have any difficulty with this, do let me know and I'll try to solve the problem. That's all for now. Thank you so much.